Welcome back, fellow nerds. In today's video we will continue looking at some questions, specifically one question. In today's video we are going to look at question 4. We did these other questions in the previous video, in one of them in which we introduced vectors themselves, and in the other one we did a few other questions. In this one we'll do another question. Like we said, exposure to lots of questions will help you get better, get more understanding on the concept. Exactly, and that's exactly what we aim at helping you with. Okay, so let's get into it. So question 4, a commuter airplane starts from an airport and detects the route shown in that figure. All right, the plane. All right, we can redraw this figure for us to better understand the concept, right? Okay. So okay, sorry. All right. This is your negative x, positive x. This is your x-axis. This is your y-axis. This is positive. This is negative, right? Okay. So the first data is the plane travels 30 degrees 175 kilometers. Okay. North of east. All right. For those that watched the previous video, you can easily get the concept from here. For those that are watching this one for the first time, that did not watch the previous one, well, you can still get the concept here. All right, this is the compass, right? In the previous video, we talked more of how you can use the compass to denote direction. Okay, so the direction is north of east, which is basically this. Okay. East is here. North of it is going up, right? So you're literally moving your angle up east till it makes 30 degrees. This is basically that, and that is the 175 kilometers. So basically on the XY plane you have that 30 degrees, 175 kilometers. This is your A. Addition of vectors, again in the previous video we talked of addition of vectors follows the rule head to tail. So the head of the first vector to the tail of the second vector. Second vector is vector B because that is where it travels next. Next it flies 150 kilometers, 20 degrees of west, 20 degrees west of north to city B. All right, again for adding vector we are going to assume this is its actual origin, right? This is where B is starting from. So this is its origin. And we use coordinate system exactly at that point, but while still following the rule head to tail. So its tail will start from there again because this is where its origin is coming from. What is the direction? We are saying it flies 150 degrees, 20 degrees, 150 kilometers, 20 degrees west of north. Again, the compass, west of north is this, right? West of north. This is north, its west is moving this side, right? Moving like that. So moving like that should make 20 degrees. So literally from here moving like this should give you 20 degrees there. So this should be your 20 degrees. This should be 150 kilometers. This should be B. This is its head. This is its tail, head to tail. And again, by compass, this is your northwest, 20 degrees north west of north. Okay, that is B. Next is city C. Find the location of city C relative to the location of the starting point. Oh, that's a question. Finally, the plane flies 190 kilometers due west to city C. Again, vector C will start from exactly there. Okay, again it will join B, head to tail. So B's head will join C's tail, and C will move 190 kilometers due west, which is basically west is this way. This is basically along the x-axis. Okay, this is your C with 190 kilometers, right? This is your C. Okay, the question is Find the location of city C relative to the location of the starting point. Relative to the location of the where is your starting point? Where did this airplane start from eventually? Initially, where did it start from? This is its origin, right? So how do we add vectors? You add vectors starting, so you draw a resultant vector starting from the tail of the first vector, which is vector A, to the head of the last vector, which is vector C. So from the tail directly to the head of the last vector. This is going to be your resultant vector. Now this diagram does look like this one, doesn't it? Exactly. So for those that did not entirely understand how this was coming about, this is exactly what happened. Okay, so I mean it's not as clear, it's not as straight because freehand, that was drawn to scan, you know. Hands. Anyway, let's continue. So our question is to find the resultant vector. All right, how do we find the resultant vector? Okay, so in the previous video we learned resultant vector has components, x and y components. Why? Because there are parts that project in the x-axis and in the y-axis for a vector that is placed in the xy plane, in a space of xy plane coordinate system. All right, so we have to find vector component x and vector component y. How? So all these individual vectors that we are adding have components, right? Because they are resultant vectors of with individual components that entirely will come up with the actual resultant vector. What does that mean? Okay, so we'll say vector A, vector B, vector C. We'll make a table, right? Okay, has its own Vx, Vy, right? So we'll make a table. Okay, we'll make a table like that. Okay, so vector A has got its individual vector component x and its individual vector component y. So we'll add all vector components x of A, B, C to get the total sum of vector component x, and we'll do the same on the y to give us a resultant vector component x and component y. So you make a table, makes it easier that way. All right, and from the previous video we'll also learn over how to find these individual components. So Vy, we'll have to say sine theta multiplied by V, Vx cos theta multiplied by V, right? The previous video will help with that. Okay, so we will get into it. We will find the vector x, then we'll find the vector y, right? Okay, so let's begin. So vector x for A, comma, will be, all right, so we've said x is what? X is cos theta V. All right, so Vx is equal to cos theta. What is for A? Cos theta. Theta is the angle, right? We said in the previous video the angle should always come from the positive x-axis, right? So we already drew the 30 degrees and where it was coming from, it was indeed coming from the positive x-axis, right? So when you remember, when you can get back to it, this is your positive x-axis, like we said, this is your negative x-axis, and this angle was coming directly from the positive x-axis, so we get it as it is. So we'll say cos bracket 30 degrees multiplied by that is 175 kilometers. So you get your calculator. So cos 30 degrees multiplied by 175 will give you, so Vx will give you 151.6 kilometers. Okay, we'll also do that for B. B will be cos angle multiplied by V. The angle again should come from the positive x-axis. Okay, from the positive x-axis. What was B's angle? So in the question, B was given 20 degrees west of north. Now, is 20 degrees coming from the positive x-axis? No, it is not. It looks like it's coming from the positive y-axis, is it not? Exactly, it's coming from there, going there. But we need one coming from where? The positive x-axis. So you are getting the angle from here all the way to there, which means you just have to add a 90, right? Because this whole section is 90 degrees plus a 20 degrees to get the accurate angle you're looking for. So 90 plus 20, that is 110 degrees. In that case, our cos for B will be angle degree will be 180. Okay, so cos 180 degrees, our vector is 150. This is our magnitude, right? 150 kilometers. So again, use your calculator. Cos 180 degrees, that's -1 times oh, sorry. This is 110 degrees. This is B, right? This is B. Sorry. Okay, so 110 degrees. So cos 110 degrees, okay, multiplied by 150. This should give you -51.303. That's just -51.3 kilometers. Okay, then we find for x cos theta magnitude. What is the angle for x? What is the angle for C? Okay, so C was along west. Is it exactly 190 kilometers along the negative x-axis? Again, our angle should come from the positive x-axis, so we will travel from the positive x-axis till we meet the vector, right? Till we meet the vector, there, we make what angle? 180 degrees. Okay, so C Vx, this is going to be cos 180 degrees multiplied by, this is V, this is the magnitude, which is what? Which is 190 kilometers. Okay, so again, cos 180 degrees multiplied by 190, that is going to be -190 kilometers. This is Vx for C. All right, then we'll place all these items in our table. Okay, so here we'll have 151.6, right? B, we have -51.3. C has -190. Okay, so you can just say brackets kilometers. Okay, all right, we'll add all this. Let's first find y, then we come and add all that. Okay, so again, Vy for A is going to be sine theta, magnitude 175 kilometer. So this is going to be sine 30 degrees multiplied by 175 kilometers. That's going to give us what? So sine 30 multiplied by 175, so this is going to be 87.5 kilometers. This is for A. Okay, B will be sine theta multiplied by its magnitude, so Vy is equal to sine, what is our angle? 110 degrees, right? Magnitude 150 kilometers. Okay, so sine 110 multiplied by 150, so we'll have 140.95, let's just say 141 kilometers. All right, okay, so C will have Vy is equal to sine theta V. So what is sine theta? Sine, what is our angle? 180 degrees. What is our V? Our magnitude 190 kilometers. Okay, so sine, open brackets, 180 degrees, close brackets, that is 0, right? So more basically here we have 0. Okay, then we go places in our table. So in our table we have 87.5, right? Then here you have 141, right? Then here we have 0. Okay, all right, then we can add all these to get our result and vector x, and we can add all these to get our sum, our resultant vector component y. So let's start with the x. 151.6 plus, open brackets, -51.3, close brackets, plus, open brackets, -190, close brackets. That is going to give you what? -89.7. all right, on the other end we have 87.5, plus 141 plus 0, that should give you 228.5. okay, then this is your x, this is your y. All right, how do we find the resultant vector? So in the previous video we learned how to find the resultant vector using that formula, vx squared plus vy squared. So we'll have that. What is our x? What is our x? What is our resultant vector x? What is our resultant vector x? Negative 89.7, negative 89.7, negative 89.7 squared plus, what is our y? Our y is 228.5 squared. Okay, you know, mathematics here, there you can just negative 89.7 squared plus 228.5, right, squared. Then you can square that whole thing, and that should give you resultant vector to be 245.4757. Anyway, we can leave it to three significant figures, which should just be that. Okay, 245 kilometers. Or you can, I mean, depending on the specifications, if you've been taught to write it up with one decimal place, you can do the 7 plus 4 plus 1 4, but stuff like that. You can get the whole decimal idea, and you'll have 245.5. But without such specificity, you can just stick to, yeah, okay, without specifications like that, you can just stick to three significant figures. All right, unless you have been given some sort of specificity. Otherwise, it is okay just to do that. Okay, so we have that's our magnitude. All right, how do we find our direction? Because if it's a vector, we also have to find the direction, which in this case is the angle. And if we remember very well our angle in the previous video, we found out that it is, I mean, it uses this kind of formula. All right, so we'll get into it to find our angle. So our angle is going to be tan inverse, that is component y. What is component y? Component y was what? Component y was 228, so we'll say component y was 228.5 over negative 89.7. Now we know a negative does not, so our x is always a modulus, right? Because we just ignore the negative. Not really ignore, but when it's in modulus, it gets cancelled out, right? The negative is only there to denote from what axis is this angle coming from. So if you have a negative on your x, according to the previous video, we knew that, we learned that it is coming from the negative x-axis if your x is a negative. So we won't consider this angle as the actual angle or the actual direction we are going with. Okay, so basically if that that negative is going to cancel out, will remain with 228.5, 89.7. okay, so we can find the angle. So 228.5 divided by 89.7, then we can say shift tan, open brackets, answer, close brackets. That should give you angle 68.5, so we just 68.6 degrees. Okay, but this is not the angle we are looking for. Why? Because this angle is coming from what? From what axis? Negative x-axis. We are always looking for an angle coming from where? The positive x-axis. Okay, so how do we do that? Again, in the previous video we learned over quadrants, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, we learned in quadrant 2 you have to subtract the angle from 180, because if this angle is coming from a negative x-axis, which is this side, which means the angle was moving like that, coming from this side to make 68.5. Is that it? Yes, 68.6. okay, but the angle we're looking for should come from the positive x-axis. right? So basically we're going to say 180 degrees minus 68.6 degrees, which should give you what? So 180 minus 68.6 should give you 111.4 degrees. Okay, all right. So how do we then answer this in totality? So we'll say location is equal to 245 kilometers, comma 111.4 degrees from the positive x-axis. Or for those that would want to use the compass, which we also learned in the previous video, you can go by, okay, again we learned of the compass. What is this angle? This angle is here, right? This whole angle. All right, if we're going to use the compass, knowing we have north, west, east, south, right? And our angle is this whole thing, right? We can just, again, the previous video we explained a bit more on that, but we can just stick to this angle. We can stick to this angle and denote it as west of north, right? And so we can, since this whole angle is 111.4, we can just minus 90 from it to get this small angle here, right? So we can say 111.4 degrees minus 90 degrees. So 111.4 minus 90 degrees should give you 21.4 degrees, which should be this small angle here, right? So having that small angle, we can then rewrite this as 245 kilometers, comma 21.4 degrees. That should be west of north. Yeah, the W should make sense. Okay, west of north. This is how you can write it. But again, we said if you're given like this, like in the previous, like it is in the same question earlier, we were given a direction in compass, but you'll always have to get the actual angle from the positive x-axis. So even this, a physicist should know that the angle has just been cut. It's not entirely coming from the positive x-axis, and so you should get the one coming from the positive x-axis. So you add the 90 to the 21.4 to get the full angle you should actually consider. But with location, you can stick to the compass, or you can just stick to the, the axis, which should be easier. But you can always want to look flashy and smart. Well, it doesn't really matter, we all get the same answer anyway. So you can leave it like that or like that. Basically, this is what you do with this question. And yeah, I hope we've learned something. I hope to meet in the next video. We will look at some more questions. Again, repetition helps cement, helps in also memory retention. So easier to remember concepts if you've actually solved a bunch of questions. Well, see you later.